Hi everyone. Today we're going to go over the study guide and review some of the answers before your test that you're about to take. So to get started on questions 1, 2, and 3, please make sure you are reading the directions. Alright, I say that because I tell you that you can use whichever method you prefer. Okay, whether you like using the graphing method or the substitution method, which we talked about in Unit 4. Either one of those will be valid, and I provided you space here on these questions if you want to use the substitution method, or I also provided you with graphs if you prefer the graphing method. Alright, so don't feel that since both of those are there that you have to use them both. If you like one method over the other, please make sure that you just stick to that method. Alright, as I answer these questions, I will be going over both methods. I'm going to swap from graphing to substitution back to graphing on these questions. There's really no reason why I'm doing that. It's just to get some practice in and show you guys both methods. If you did use the other method that I don't show, just check your answer at the end and you should get the same thing regardless. And if not, we can work backwards and help you from there if we need to. Alright. So to get started, on question 1, if you take a look at both of our functions, they both say y equals, and so they're actually both in slope-intercept form. So the reason why I'm going to choose to graph question 1 is because they're both in mx plus b form. They're ready to go. And so what that means is for the first function, I'm going to say, well, my slope is 1/3, and my b is a positive 1. And by knowing that information, I can put that on my graph. So at 1, I can put a point, and then my slope is going to tell me that I want to go up 1, and I want to go right 3. So from the point that I just graphed, I'm going to go up 1, right 3, and I'm going to continue the pattern as much as I can to get as many points on my graph. Once I have all my points, I'm going to connect the points with a straight line. And I'm completely done with graphing that first equation. Well, there weren't only one equations, there were two. So I'm going to find the slope of the second equation and the b of the second equation. And if we look back at that second equation, there's no real number in front of that x, but we are mathematicians and we are going to remind ourselves that that is a 1. So my slope is 1. Of course, if we make it a fraction, it's going to be 1/1. And my b this time is going to be a -3. This time with this information, I get to go down 3 on my y-axis, plot my first point, and my slope is going to tell me to go up 1, right 1. So from that new point, I'm going to go up 1, right 1, up 1, right 1. Continuing the pattern as much as possible. That way I can see the exact point in which these two lines are going to cross. And when you see that exact point, that is the answer I'm looking for. Well, they are definitely crossing. It's going to take a little bit, but they do cross. And they are going to cross at the point 6, 3. And that's what I'm going to look for when I'm reading your answers when I go to grade them. Okay, make sure you give me your answers as a coordinate. Coordinate. For question 2, once we have our answer to question 1, we're going to move over to question 2. Again, you can use whichever method you prefer. Alright, taking a look at my options, I have a y equals 3x plus 3. So it's in slope-intercept form. But the second function is in 3x plus 2y equals -12. It's not in slope-intercept form. So this time, I'm going to choose to use substitution. If you guys don't want the substitution method, you can for sure do the graphing method, but you would have to rewrite this bottom function into slope-intercept form. So you have that added step. I'm going to choose the substitution method. That one tells me that if I know what my first function has to equal, I'm going to take that function and plug it in for my y in the second equation. So I'm not going to use the graph at all this time. So I'm going to have 3x, let's bring it up here, 3x plus 2, and then when I get to the y, I'm going to plug in a 3x plus 3, with parentheses, don't forget that, and it still equals negative 12. All you have done is rewritten that y portion. Now let's distribute our parentheses. 2 times 3x was going to give me 6x. 2 times 3 is going to give me a positive 6. And I get to bring down everything else that I haven't changed. Now I get to combine my like terms, and the reason I get to combine them is because they are on the same side. So a 3x and a 6x are going to combine to give me 9x. Plus 6 is still equal to negative 12. Continue solving for x. That's going to make me have to subtract a 6 to both sides, giving me 9x is equal to negative 18. Dividing both sides by 9 now, and you will see that x is equal to negative 2. Well, I know x equals negative 2, but I'm missing that second part. I also need to know my y. You got to submit your final answer as a coordinate. So as soon as I know my x is negative 2, I'm going to go back to the equation I started with because my y is completely ready to go, and so I can solve for it. So I have a y equals 3. Remember, we just solved for x. We got negative 2 plus 3. Plug that into my calculator, and that's going to tell me that y is equal to negative 3. And by doing that, I now know my x, I know my y, so I can submit my final answer as negative 2, comma, negative 3. And I didn't need a graph for that one. Of course, if you like the graphing method, you should have the same exact answer at the end. Negative 2, comma, negative 3. All right. For the last question, you can do the graphing method. You can do the substitution method. Again, either one that you prefer. I'm going to use the graphing method because I see that they're both not in slope-intercept form. So no matter what, I'm going to have to convert one of them. So I'm going to choose, well, if I have to convert one of them, why not convert both and then just bust out a graph? All right, that's what I'm looking for. So I'm going to take the first function, 2x plus 3y equals 6. And I'm going to subtract a 2x so that I can move it to the other side. Remember that when you subtract a 2x to both sides, they cannot combine with that number all by itself. So the 2x and the 6 need to stay separate from one another. Divide everything by 3, and that's going to give me the function y equals negative 2 over 3x plus 2. Now I can find my m, I can find my b, and I can make my picture of that first line. So my b is 2. My slope is going to tell me I need to go down 2, right 3. Down 2, right 3. Continue the pattern to get as many points on your graph as possible. And when we have those points, we can make our line. Well, I have the first line completed. Now I just need the second line. So I'm going to now take the 4x minus 6y equals 12 function, and I'm going to solve for y again. So I subtract a 4x this time to both sides. That gives me negative 6y. Don't forget the negative, that's still there. Equals negative 4x plus 12. Divide everything by negative 6. And that is going to give me y equals, and when you look at the negative 4 over negative 6, it will come out positive, and we can also reduce that fraction. So when we reduce the fraction, we'll get 2/3 x minus 2. So if you notice, the slopes are the same fraction, just one's negative and one's positive. So I still graph at negative 2 for my b, and this time I'm going to go up 2, right 3. Up 2, right 3. And when you do that, you will see that these lines will cross one another. And then you just need to tell me where they're going to cross, and that point is going to be at 0, not 0, 3, actually the other way. 3 first on your x, followed by 0 on your y. 3, 0. The first 3 questions, take a look. They all crossed at exactly 1 point. We didn't graph on question 2. If you graphed on question 2, that's fine. I just chose the substitution method so that we could go over that as well. All right. You can always, always, always graph every single time. So I wanted to provide you pictures so that you can do so. Questions 4 and 5 are very, very similar to questions 1, 2, and 3. Except for these, the directions ask you which one are you going to have, no solution or infinitely many solutions. So based off of the question, we automatically know that we're not going to have pictures that will look like 1 and 2 and 3 because we know that they're never going to cross. We know that it's either infinitely many solutions or no solutions. That's my options. All right, so I'm going to do substitution and graphing again. And for this first one, I will do the graphing method. So if I were to graph this first function, my slope would be 5, and my b would be -3. So that tells me I'm starting at -3, and I'm going to go up 5 and right 1. Get as many points as possible. This time we can only get 1 point, or 2 points rather. Make my line. The second function says 5x minus y equals 3. Well, this function is not in slope-intercept form, so I need to move things around to get it into slope-intercept form by subtracting a 5x to both sides. That's going to leave me with -y equals -5x plus 3. And then in order to get rid of that negative in front of my y, I need to divide everything by -1. So I'm really working with y is equal to positive 5x minus 3, which will give me a slope of 5. Notice it's the same slope. And a b value of -3. Notice it's the same b value. So if I did that, I'd graph it on the same exact point I was at earlier. And I'd go up 5 and right 3. What happens when I connect these dots this time for my second line? Well, my lines are showing that I'm overlapping. So not only am I touching this graph one time, but I'm touching it so many times that I can't even keep track. So I have infinitely many solutions. They are always crossing one another. All right. For question 5, I will use the substitution method. Again, if you like the graphing method, you can use that. That's totally fine. And I get to take this function now, and I'm going to replace it with my y on the other function. So that's going to give me a 2 parentheses 3x plus 4 equals 6x plus 4. Continuing on, I'm going to distribute my 2 into the parentheses, giving me a 6x plus 8 equals 6x plus 4. And when you notice, your x terms are on opposite sides of that equal sign, so I cannot combine them as they are. I have to move them, or move one of them. So I'm going to move that 6x that falls on the right side of that equal sign. So that tells me, oops, there we go. That tells me I want to subtract a 6x, and whatever I do to one side, I get to do to the other. Well, take a look at what happens here when I subtract 6x. They're going to cancel, leaving me with an 8, canceling again, equals 4. So when I get here, I say, well, does 8 really equal 4? No, it does not. So that is a false statement, therefore, there are no solutions. And if you made a graph on this question, you would notice that your slopes would have to be the same, which would make your picture, your two lines, have to be parallel to one another, which means they will never cross, hence also no solution. So as we go down, questions 6 and 7 are exactly the same on your test as well. So make sure this is something that you will see on your final as well. Make sure that we're understanding the ideas here. So for question 6, there are 2 lines presented to us on this graph. And we are asked to basically figure out what those equations are. Okay? And the beauty of these questions is that we can eliminate answers as soon as we identify something special about these graphs. Alright, so I want you to look at this first line here. And I want you to identify that, well, this first line is solid. And whenever I see solid lines, I have to have inequalities that have equal signs. Okay? Keeping that in mind, let's look at the second line here. That is also a solid line. So again, I need inequalities that have equal signs. Well, if both of my functions have to have an equal sign, that's automatically going to cross out options A and B from my list. And I'm left with C and D. Okay? This will be just like your final. You'll have multiple choice options. Once you eliminate stuff, use what you see in the answers to help guide your thinking. Alright, you know the answer has to be either C or D, so let's use the answer to our advantage. If you compare that first portion, C and D, to each other, they're the exact same. So let's not focus on this portion, that x is less than or equal to -1. Let's focus on the second functions here. Alright? And the beauty of this is that they're in slope-intercept form. We know how to graph slope-intercept form. So if I were to look at this line, it's talking about this line right here. Let's see if we can identify our B. Where are you crossing the y-intercept? And if you look closely, you will see that you're crossing at the point 2. So double check, look and see at your function, see if there's a 2 that lives there, and there is, so that's no different. The thing that's different between these two answers are the slopes in that slope-intercept form. So that should be the key that we're going to go in and look for when it comes to this line. How far down am I going? How far to the right am I going? So if I look at this same line, I'm going to take this point on my y-axis because it's crossing really, really nicely. And the other point that's going to cross nicely is this one down here. Okay? Use those boxes, use those squares to help you. If it's crossing in all 4 corners of a square, you are good to use that as one of your points. Well, if I'm looking at my 2 points, let's see my rise over run. So I went down 2, and then I went over 5. So that's going to make my slope be -2 to the right 5. Take a look at our options. Well, the only slope that says -2 over 5 is going to be option C. And there you have it. Looking at question 7, look at your clues again. This time I have a dashed line. So think about your only options. You can only have a less than, or you can have a greater than. You cannot have an equal sign. So right away you can cancel out C and D. And then when you look at your options, you have A and B left, and the only thing that's different between A and B is whether it's a less than or a greater than. So that's where we want to look at the shading. Alright? Take a look at this y value on the y-axis on this line. It's at -3. Well, when I compare this value to everything that's shaded, is it everything shaded greater than -3? Or everything shaded that's less than -3. And remember, you're talking about your y value, so you're going up and down when we look at the y's. So up means greater, down means less than. And when I look, I say, well, it's shaded above that line, it's shaded everything greater than that line, so I want to choose option B. Okay? Use your clues when it comes to choosing these answers. For questions 8 and 9. Alright, 8 we have to do a little bit of work. Question 9 is actually already in slope-intercept form for us, so that is nice. That will also be the case on the test. They should also be in slope-intercept form. You shouldn't have to worry about changing anything. But we'll get that some practice in some more. So for question 8, you have negative x plus 2y is less than or equal to negative 4. We don't see this in slope-intercept form, so we need to move the x term over. That's going to give me a 2y is less than or equal to x minus 4. Dividing everything by 2, and that's going to give me y is less than or equal to 1 over 2x minus 2. This will also tell me that it's going to be a solid line when I go to graph it. And so if I know this already, if it's in slope-intercept form, let's make a graph right away. So I'm at negative 2. And then my slope's going to tell me I'm going up 1, right 2. Up 1, right 2. Get as many points as you can. And then when we get to connect the dots, we can use a solid line. Last but not least, we want to check and see where it's going to get shaded. And if we look, it's telling us that y needs to be everything less than that function. So it's going to be everything below that line. And since I have a second line that's going to need to be graphed, I'm just going to draw in these arrows so that I remember later where I have to shade. And now we get to do the same thing all over again for this second function. 3x plus 2y is greater than or equal to 6. Subtract a 3x to both sides. We get 2y is greater than or equal to negative 3x plus 6. Divide both sides by 2. And that gives me y is greater than or equal to negative 3 over 2x plus 3. Looking at my function, again, I'm going to have a solid line. So I can put a point at 3, and it's telling me I need to go down 3, right 2. Down 3, right 2. Down 3, right 2. And when I connect the dots, I get to use a solid line. And when I get to shading this time, it's telling me I want to shade everything greater than that line. So I want to shade everything above that line. So I draw in my arrows to remind me where they're going to get shaded. And last but not least, when I look at where those arrows are all pointing, the section where they both get to be pointed to is right in here. So that will be my final answer. Everything that's in this section will get counted as an answer. Doesn't matter what it is, whatever coordinate it is, as long as it's in this shaded area, it is counted. And you're all done. We get to do the same thing with question 9. Again, on the test, it will look like question 9. It's already in slope-intercept form. Both of these questions on the test should be in slope-intercept form. So we don't need to rewrite them, or we shouldn't need to. So for this first one, I have m is 5, and a b is negative 1. So I can graph that at negative 1 with a slope of 5. So that tells me I need to go up 5 and right 1. I can also go down 5 and left 1. And when I make my line, I want to make a solid line when I connect my dots. Take a look at your function. This time it's telling you it wants everything less than 5x minus 1. So if we take a look at our y-intercept, this negative 1 here, I want everything less than that negative 1. So that's going to tell me that I want to shade everything to the bottom of negative 1. So I'll draw my arrows to remind me that's where I'm going to shade. And then I go to the second function and identify my slope and my b. And then make my graph again, down 3, right 1 this time. And the second line, looking back at that inequality, is going to tell me it's a dashed line. So I'm going to draw in a dashed line. And it's asking for everything greater than that line, so I have to shade everything above it. And the section that's going to get both shaded areas is going to be this section here. All of it, make sure that it's clear as day to me so I can make sure that this is the shaded area at the end of everything. And you will be all good. Inequalities, make sure we shade. Don't forget that step. Okay, remember, if you were at a roller coaster and you had to be 5 feet tall to get on that roller coaster, anyone that's greater than 5 feet tall can get on. That's exactly what these inequalities are telling us. Anything in this shaded area can get on that roller coaster because there's more than one option, just like there's more than one option of anything more than 5 feet. That's why we shade when it comes to inequalities. All right. For question 10, you have the point 6, 3, and it's asking if it's a possible solution to the following inequalities and explain why or why not. All right. So this one is going to take some brain work. For the first question, or for the first function, y is greater than 2, we actually do have a slope and we do have a b. But we have no x term. And by having absolutely no x term at all, that tells us our slope is 0. Whereas our b is 2. And if you remember how these functions will look, they're actually going to be a straight horizontal line back and forth. And if I asked you for everything greater than that value, you're going to do everything above because it's in respect to your y's. The second function, however, 4x minus 4y is greater than 12. We need to rewrite it, subtracting a 4x to both sides. You see how this pattern is constantly continuing and coming up over and over and over again? Make sure we know how to convert. We want to divide by 4 next. We want to divide by negative 4. So what's actually going to happen is you just divided by a negative number and you're working with an inequality. So it's going to flip the inequality. Don't forget that rule. Every once in a while it will come up. That's going to make it an x minus 3, which tells me I have a slope of 1 and a b value at negative 3. Graph what I know. And this time my line is going to need to be a dashed line. And when I go to shade, based off of my new function, I want to shade everything below. And so the only section that's going to get combined here is this section right here only. A little spot. So when I go back to the main question, asking if 6, 3 is a solution, well, let's go find 6, 3. That's going to be right here. All right, this is a trick question. I understand it's very, very close to the shaded area. However, what kind of line is 6, 3 currently on? All right, it's on a dashed line. And why there is a difference between dashed lines and solid lines is because anything that lives on that dashed line is going to be considered not inclusive. We are not going to include it. That's why there are dashes, to show that there are gaps within that line that are not included. So because 6, 3 is on the dashed line, it is not a solution. And that is our explanation, because it is on a dashed line. If it was on a solid line, we would be fine. But this time it's on a dashed line. And last but not least, we have question 11. 11 is just like the extra credit. You will have extra credit on your test. Alright, so please make sure you give that a try on the test. It says evaluate each function for x equals -5, and then give your final answer as a coordinate. So all we need to do is replace every single x that we see with the number -5. And as soon as we see that, we can use the calculator to help give us our final answer. So for this first one, it's going to be f of -5, because we're replacing x, equals 2 parentheses, again, replacing x, 2 parentheses -5 plus 14. Type that into my calculator, and we should get a nice positive 4. Remember, I want your answer as a coordinate, so you're going to say -5 for your x, and your y will come out as positive 4. Follow that same routine for the other questions. Just plug it in, make the calculator do the math. I believe this one should give us a 3. Yep. Therefore, the coordinate is -5, 3. And for the last one here, it is going to take a little bit of work, but we got this. We're replacing our x value with -5. Just because there's already a set of parentheses there, don't forget to still add your own parentheses. We can do the right-hand side on the calculator here, so that's going to give me 8. And I still have a -5 and a y. And when I keep solving, I'm going to add a 5 to both sides. So that's going to tell me that my y equals 13. That's exactly what I'm looking for. So now I have the coordinate -5.